Integrating AWS appsync GraphQL into Godot, especially handling SIGV4 signatures, real-time WebSocket subscriptions, and custom resolvers is notoriously tedious. Writing custom authentication headers and parsing raw JSON responses manually in GDScript takes weeks and slows down your development. That's why we built the AWS appsync GraphQL add-on for Godot. It gives you a complete GDScript native solution to connect your game client directly to AWS appsync. Built specifically for Godot 4, all GraphQL requests and subscriptions are latency functions you can call asynchronously using simple await keywords. Even better, we've wrapped all GraphQL responses and subscription messages into dedicated GDScript classes, making autocompletion, data extraction, and response handling completely effortless in the editor. Under the hood, the add-on includes our built-in AWS_authorization_helper class. It automatically calculates all required authentication headers for your GraphQL query and mutation requests, query parameters for your subscription connections, and the embedded authorization payload for your start subscription messages. Whether you're securing your API with an API key, an OIDC access token from Cognito, or full AWS IAM credentials. To give you a complete end-to-end backend pipeline out of the box, we've included a full example project with ready-to-deploy backend code. Let's look at how to build, upload, and deploy the entire backend stack step by step. First, let's build our appsync resolvers. Open the TypeScript resolver project, which is fully customizable, run npm install, and execute npm run build to output your compiled resolvers directly into the dist folder. Next, open the Python Lambda project, which is also easily customizable to fit your game logic. Run the included zip.py script to automatically package your Python Lambda files into a single zip file inside the zipped folder. Now, open the S3 bucket we created in our previous video. Inside this bucket, create 3 folders: CloudFormation_template, appsync_resolver, and lambda_function. First, upload our CloudFormation templates, including our main template, aws template.yaml, and its nested Cognito and GameLift templates, into the CloudFormation_template folder. Second, upload the contents of the TypeScript resolver project's dist folder into the appsync_resolver folder. Third, upload the contents of the Python Lambda project's zipped folder into the lambda_function folder. Once uploaded, navigate into the CloudFormation_template folder. Select aws template.yaml and copy its object URL. Head over to the AWS CloudFormation console, choose Create Stack with New Resources. Paste the object URL as your Amazon S3 URL template source and click Next. Configure your stack parameters, including your S3 bucket name and resource paths. For local game server testing, set the Deploy Game Server parameter to use a local test fleet instead of a managed EC2 fleet, and hit Deploy. In just a few moments, AWS CloudFormation automatically provisions your entire backend, including Cognito, GameLift, appsync GraphQL API, resolvers, and Lambda functions. Once the stack finishes deployment, head to the Outputs tab. Copy your AWS region, GraphQL endpoint, real-time endpoint, GraphQL host, and the rest of the required output values. Don't forget to click the generated link to your Cognito user pool client settings to copy your client secret as well. Now, open the example project in Godot, navigate to scenes/main.tscn, select the main node, and head to the game instance section inside the inspector doc. Paste all your copied AWS and appsync parameters directly into their corresponding fields. Since we selected local testing for GameLift, you'll also need your local server's WebSocket URL and auth token. If you need a refresher on how to run register-computer and get-computer-auth-token to get those values, check out our previous GameLift video linked in the description below. Once you have those 2 values, paste your WebSocket URL and auth token right into the game instance inspector as well, and your project setup is complete.
Now, let's run two packaged client builds side by side to test our real-time friend system in action. We'll log into the left client as test user 1 and the right client as test user 2. When test user 1 sends a friend request using an asynchronous GraphQL mutation, test user 2 receives it instantly through their live WebSocket subscription. If test user 1 cancels the request, it disappears from test user 2's screen immediately. If test user 1 sends the request again and test user 2 rejects it, the update streams back to test user 1 in real time. When test user 1 sends a third request and test user 2 accepts it, the system moves them both into the active friends list instantly across both clients. Finally, when test user 2 removes test user 1, the friend list updates dynamically on both sides without requiring any UI refreshes. You can pick up the aws appsync GraphQL add-on, download the complete example project with TypeScript resolvers, Python lambdas, and CloudFormation templates down in the video description. If you found this video helpful, please hit that like button, subscribe for more Godot backend tutorials, and leave a comment down below to let us know what you think or what you'd like to see next. Also, don't forget to jump into our Discord community to connect with us directly. Thanks for watching, and happy game developing!